Here we are at Logarithms Part 5, and I want to remind you of the log rules, which are very important. The definition, log base b of a, b is greater than 0, b cannot equal 1, and a has to be greater than 0. It cannot be negative or 0. Also, here's all of our log rules over here. And again, the reminder that you cannot have a negative with the logarithm. It's not a real answer. There is a complex answer, as this problem would have. So now we move on to problem number 20 to solve logarithms for part 5. And you'll notice here that this looks like a long problem. You'll notice the plus here, which kind of ought to remind us of this plus down here. That indicates a single logarithm that is a product. The base is e all the way through the problem, a consistent base. And so we would want to bring these two terms, these antilogs, together and multiply them. And notice we have a single log on the left, we have a single log on the right, both bases. That means we can take the antilogs and set them equal to each other. I FOILed this out, multiplied this out, combine like terms, and even if factors. And when it factors, these factors are set equal to 0 by the zero product theorem, and our solutions are 6 and 1. There's a little problem here that we want to watch, and that is when we plug this in up above, you'll notice that this quantity right here becomes a negative 1. So does this one. And if you remember, that, according to this rule up here, is not allowed. So that is not a real number, so it's not possible to get an answer there. And so I have another answer, which is 6. So I'm going to want to plug that in also. And of course, when I do, I get a 4 here. A 9 here with a plus means multiplication. And that gives me 36. Over here on the other side, I have the power rule reversed, and that gives me 6 squared, which again is 36. And so this answer 6 checks, but the negative 1 does not check. Let's move on. The next problem is a base 10. Again, we're solving for x. And because of this 4 in front, we want to move that over to its like term by division, because that's multiplication. We reverse it and divide. We have a base 10, so we write an exponential. Doesn't look very nice, but this is what it looks like, and then we add 6 to the other side. And of course, we must do 10 to the parentheses 11 divided by 4 in order to keep that straight. So our answer is 569.34. Again, that's an about answer. That's not an exact answer, but it's really close. And we have another logarithm here, which is a natural log. So that means you divide by 2, which gives you 7 halves, or 3.5. And you'll notice here the base is e, so we rewrite as a natural log exponential and put this under our calculator, and we get approximately 53.115. And the next slide, we go on to another logarithm problem, a base 10. In order to get x out of there, we need to reverse the problem. So we're going to write it as an exponential. I hope you're getting this, rewriting logarithms as exponentials. So many problems follow this pattern. Subtract the 1 to the other side, and then that's equal to x squared, and then we have to square root it. This, of course, ends up giving us approximately the square root of 10 to the 8th, which is 10 to the 4th, which is 10,000. This little 1 here, when it's subtracted from it, drops us slightly below 10,000. Notice there's two answers. When you do square rooting, you get two answers. One's plus and one's minus. And if you plug them in up here, they'll both check because we're squaring them both. These are the x-intercepts of this graph, this logarithm graph. On we go to a very similar problem, a little easier. And again, we have a base 10 that we want to write. We use our exponent. 6 is our exponent. A 10 is our base. So again, this is 10 to the 6th equals x squared. Square root both sides and you get plus or minus 10 to the 3rd, which is plus or minus 1,000. And both of those are going to check as they are. Let's go on to another one. This is a square root, even though it doesn't show very well. The square root goes over the top of the x minus 8. We have a couple of choices on this. One choice is to put a half power up here because the square root is a half power. And because of the power rule down here, this last one, these two bases do not match. B is E in our case, and U. So we take the power and we put it in front. So we take the half, put it in front, reciprocate, and multiply times 2. And we get 10. And so now we're ready to write as a base E of the exponent 10 equals x minus 8, and add 8 across, e to the 10th plus 8. Put this on your calculator and practice this. This is exactly where you need to practice. And it comes out to one large answer, which looks like it'll be pretty good up here as far as checking because it's a positive number. Okay, number 27. We did one like this just before, not too many tries back. It's worth it to try it again. Again, the easiest way is to add natural log of 2 across the equal sign. And now we have the bases are equal. Notice they're both base E. We have single logs with bases equal. Therefore, the antilogs must be equal. Let's go on to the next one. This one is an exponential. We've had many logarithms we've started with. This is an exponential, base E. To get the x out of there, we want to write it as a natural log. Here this E is actually right here. This is what ln implies, base E. Our power here went to the other side. Our solution is to add 2 across, and we have to divide by this negative sign. And when we do, we end up with a negative 8.0061, which actually turns into a positive exponent when you plug it in. Okay, and on we go to another exponential. Notice we got to get the exponential by itself. And it's good for you to stop and work these problems and then proceed with me so you know what you're doing. You only learn how to do this by practice and not by watching me. But hopefully you'll learn a few things. So you'll notice here we divide by 1,000 on both sides. The 1,000 cancels on the left. 75 over 1,000 is the decimal. 0.075, just like it reads, 75 thousandths, and that's what this reads, 75 thousandths. So got to get x out of there, so that means I need to write it as a natural log, base E. Here comes my value right here, my antholog. This is my exponent. I have to divide by a -4. Pop this onto the calculator. Again, make sure you're doing this right with parentheses. Don't guess. Make sure. And so apparently this came out as a negative number. Divided by a negative gives me a positive right here. Okay, another log. I put the base here, log base 10 of x minus 2. You'll notice that this This does not have a parentheses around it, so it's not joined together. So that means this 2 is going to have to go across the equal sign. A lot of people would miss this on that step, especially since we've done so many with the parentheses on it. And again, this is a base 10 to the second power. That's exactly 100. There's no rounding off on that. Well, this is the end of the fifth practice through logarithms. You've seen a lot of logarithms. There is, yes there is, a part 6. So I hope this helps you in your pursuit of understanding logarithms, especially knowing these log rules. If you don't memorize these log rules, proceeding forward is going to be very slow for you. You'll have very little recall. And the way you must work on memorization of definitions, of basics like these first 3, and of the last several log rules. Hope this helps you. And on we go to the 6th